Hey folks, Professor Finn here, and now we're going to be going on to the next chapter in the 6th edition of the Embalming book, The Prep Room. Let's go ahead and get started. So the primary purpose of a well-designed and organized prep room is to provide a safe, efficient, and comfortable environment for its workers. Believe it or not. Funeral homes and decedent care facilities are governed by a variety of laws and regulations from all levels of government. A best practice is to consult with experts in the field to assure adherence and observance of all requirements. So you're going to be working with your architects along with consultants maybe and local regulatory licensing commissions, whoever, to make sure your prep room meets all the requirements of your state. So, generally speaking, commonalities that apply to all prep rooms. Admittance is by authorization. So this means that no one can just kind of walk in there. So it should require some sort of key card or numeric access, something so that no one can just barge right in. The room is kept strictly private during body preparation, and room signage must be in compliance with laws and regulations. As we spoke in the previous chapter, we talked about the necessity of putting signage when you exceed certain levels of formaldehyde exposure. Many funeral firms just put the signage up automatically, and a lot of states actually require you to have those formaldehyde warnings in place and biohazardous and stickers and formaldehyde stickers on your equipment, sharps containers, stuff like that. So make sure that you are aware of what those law requirements are, because sometimes they're very specific about the size of the sticker that needs to be there. The prep room should be a secure area with access controlled in a number of ways. So establish a security plan for the handling of high-profile deceased individuals. That's why many prep rooms do not have windows in modern settings. Inventory and label personal effects and securely store them. And the prep room should not be located so that it becomes a passage to other areas. So what they're saying there is if you have, If you have a room here, say a storage closet, and then your prep room is here, you should not have to go through the prep room to get to the storage closet, and you should not have to go through the prep room to get back to the main areas of the funeral home. You should be able to maintain the dignity of the remains at all time, maintain the highest ethical and moral standards of care and confidentiality. There's a tremendous amount of liability attached to the preservation and storage of human remains. So making sure that your prep room accounts for the fact that you don't want anyone taking pictures or getting in there and doing things that they shouldn't, very important task. Maintain a clean and healthy environment. Properly dispose of clothing of the deceased by either laundering and return to family or dispose of it with their authorization. So important side note here, when you pick up personal effects from the hospital, you have to sign for it. And the reason is it's not the hospital stuff. It is the decedent, now the authorized family representative, it's their stuff. So you just throwing it away, that is not your call. You should obtain authorization to throw away personal effects received from a nursing home or a morgue or whatever. There's a reason why they released it to you, because it's not their stuff. It's the stuff of the quote-unquote next of kin. Maintain an adequate supply of chemicals and associated sundry items necessary for embalming and decedent care. That seems common sense, but there are some people that will store chemicals and sundries in another location. You have to leave the prep room to go get them. That's kind of ridiculous. Maintain an adequate number of tables and positioning devices per case volume. So a good rule of thumb is don't think about just your current call volume, but think about what happens when your building or your business is going to expand. Is the room you're using going to be sufficient when you go from under 100 calls to 400 calls? If not, think about how you're going to arrange the room, especially if this is going to be new construction, so that you've anticipated this growth. Document decedent care activities for every decedent and the care of the facility, and use embalming decedent care reports and other applicable forms. Now, this is a major shift from the 5th edition of the textbook. One of the things that changes here is the fact that from the 5th edition earlier, you would just put everything on an embalming report. Not that that's a bad practice, but the issue becomes you really want to have forms for different things so that no one may connotate that you embalmed the body when you didn't embalm it. And that's really the approach the 6th edition takes. You have decedent care reports, you have embalming reports, and they are meant to show different things. Thankfully, they give you examples in the textbook later on. OSHA requirements are enforced through workplace inspections, warnings, and citations. In the event of failure to correct continual noncompliance or serious violations, substantial fines are levied. OSHA fines could easily cripple, bankrupt, and close a funeral business. Right to know laws provide workers with direct access to information about the health risks of chemicals used in the workplace, and posting requirements for this information is mandatory. You have to make sure that you have the proper things on your walls in the proper places, the proper binders or other information in certain rooms, and the employees need to know where that stuff is. So, new construction. The following floor plans in your book are examples for new preparation room construction. You have a station concept, centralized embalming. So there are lots and lots and lots of examples in the book to give you an idea of how prep rooms should be constructed. Now, a great way to see this in real life, if you're choosing to build your own firm, is simply go visit funeral homes and take a look at what they have there. A great way to do this is networking, calling peers you went to mortuary school with or working at other firms. Say, hey, would you mind if I came down and looked at your prep room trying to build one? And you may be surprised how many people just let you walk in as a licensee to kind of see what their facilities are. And that's certainly true for out of state or other areas where you are not competing. Combination funeral home and crematory operations are not allowed in some states. Be aware of what your local state regulations are. I am licensed in the state of Florida. You can have everything you want at a funeral home, a crematory, etc. But there are states like California where you cannot have a crematory on the premises of a funeral home. They're only allowed on cemetery property. New construction and facility remodeling requires a building permit, and permit application will require detailed site plans and specifications to be submitted. There is nothing about new construction that is cheap. I'll just leave it at that. Plumbing, electrical, heating, and cooling systems and other construction requirements require permitting. And having a competent architect designing and spearheading this process, very important. Best practice is to consult a professional for guidance with building ordinances. Codes and ordinances vary between localities and may change with time. A best practice is to maintain up-to-date compliance with respect to all requirements. In your book lists the minimum requirements for Ohio. So now it's going to talk a little bit about different types of rooms and their purposes. Okay, and every one of these things is testable fodder. Like every one of these things can come up. So the first is a dressing room. So why would you need a dressing room? So that when you're dressing and cosmetizing bodies, your embalmers are working in peace and not having all this extra storage lying around. A dressing room is used for purposes other than arterial embalming. It can also be called a holding or a staging area. And here's a great example of a dressing room. You have two workstations where bodies can be stored. You have all of your makeup stored right between the tables. I mean, there's a lot to like about this room that we're looking at. And that's probably why I decided to use this photo. So we're all clear. Any photo in here, if it does not appear in your textbook, citation for the photo is embedded in the metadata of the photo, and that will allow you to see where this came from. But I really like this idea of the centralized dressing room, so that way you are able to do whatever you need to do. You're not stumbling over someone else. Everything that you need, the makeup, is in a central location. Just really well laid out. Really like this one. So what can be performed in a dressing room? And a lot of states regulate what must happen in a prep room versus what happens in other rooms. So make sure you know the laws of the state in which you're practicing, because dressing rooms may be regulated just like embalming rooms. Typical activities that can occur in a dressing room or a staging area is the temporary storage, minimal prep for identification, so not really arterial embalming, but kind of brushing the hair back, maybe some airbrush cosmetic. grooming and hairstyling, restorative treatments, cosmetic application, dressing and cosmetizing, religious and cultural practices, cavity aspiration or re-aspiration. That is something that's very important that you should be able to do in and outside of your prep room. Is if you need to aspirate a body, what technology do you have in these rooms? Does it have to be portable technology? Do you have plumbing in the dressing room so that you can at least aspirate re-aspirate a body? There we go. So, don't know why my computer's lagging a little bit. Preparation room location. Different areas of the country can permit different things. So, for instance, back in Massachusetts, where I was born, basements are quite common. Florida, where I lived most of my life, basements are not very common. Here in Texas, I don't have a basement on my home here in Texas, but I believe there are some homes that do have basements. So, basement. The basement of a facility is often the space that is most readily available that you can drop in a prep room. Really, it is not the best place for a prep room because ceiling height can be limited. There are already lines and things in there that can cause complications. You might not have centralized air. Ventilation could be a problem to exhaust the fumes. Sewer drains are substantially above floor level. Plumbing challenges may be present, and without an elevator or floor lift, you're carrying things up and down stairs, and that kind of stinks. First or second floor. The first floor can be the most logical and least costly location of a prep room when space allows. Natural light is favorable for working conditions. Room access must be secure because you don't want people wandering in and out. And these days, even putting a light or a skylight on the room, you have to worry about people flying their little drones overhead to look and see what you're doing. So make sure if you are putting up windows, you'll see it later, you really want to use like frosted glass and stuff like that. Prep room size and use. Frequency of preparation room usage is the determining factor in selecting an optimal size. So if you are probably going to do less than 100 calls a year, you probably don't need a very large prep room. And if you anticipate in the community that you serve or your business model is not going to do a lot of embalming, then probably a pretty small prep room. But if you're going to be cranking out things, you probably need to have a larger prep room, and some thought needs to be put into place of how people can work without stepping over each other. So here's a good example of a two-room prep or a two-table prep room. And you can see that each embalmer can work independently. Really, the only place that there may be some catch-up is right over here in the sink area. But you can see on the other side, you have a sink there as well. So even if you need to wash your hands, you don't need to go down the middle and trip over yourself. So consider the following. Base room size and case volume, design the space for optimal efficiency, and select materials that can be efficiently cleaned and disinfected. Remember in the previous chapter we talked about the fact that you really want to clean the entirety of your prep room, your fans, your wall lights, your walls, your lights, all that sort of stuff. Well, you got to make sure that it can handle that. Install an adequate number of embalming tables. Include dressing tables if you don't have a dressing room, and include a lifting device so you're not breaking your back. Reduce the items available in the immediate prep room to include only those routinely accessed during embalming, such as instruments, fluids, sundries, and positioning devices. Realistically, you don't need to keep a lot in your prep room, right? You need your instruments, you need your eye caps, mouth formers, stuff of that nature. You don't have to do chemical storage in there. You can keep, a case on hand of whatever it is that you use from your cavity fluid, etc. But you don't have to have all of your boxes stuffed underneath countertops, especially if you have another storage area adjacent. One, then those boxes don't become contaminated when you're, doing what you do in the prep room. And two, you could use that as extra space for other things. So if we go back to this room here, you can see there is adequate storage for just about anything that you would need in this prep room. You have countertops, you have cabinets on top, you have cabinets and drawers on the bottom, and you probably even have space if you needed to do a rolling toolkit or two in there. Just a well thought out prep room. And if you look closely, you can see that there are exhaust fans right at the base of the tables. Remember, formaldehyde is a heavy gas. And look right above the machines. You have vents for the machines there as well. So as you're pouring, it's sucking the vapors into your exhaust system. Just a great example of a very well thought out prep room right there. And consult an architect with skill and experience doing prep rooms for new construction or remodeling. All you need to do is pick up any trade magazine and there will be an advertisement for someone in there. An example of a company that does this is Duncan Stewart Todd. And if you ask a firm like that, hey, can you send us some examples of work you've done, some pictures, they can do that. And then certainly follow up with references. If you call, you can even visit some of those firms. Like I said, say, hey, I'm thinking about engaging this architectural firm to remodel my prep room. Would you mind if I schedule time to come down and take a look and just talk to you about that if you're not busy, so I can get your feedback on how the process went, etc. Word of mouth is very powerful in our industry, folks. Consideration of movement and function within the prep room is paramount to its overall efficiency. You don't want to be staggering all over people. Now, at the very beginning of this presentation, I posted a picture of my lab in Miami before the remodel. And it's got 3 tables, got an overhead gallery. After the remodel, it had TVs and cameras and all sorts of stuff so that students could observe from a viewing gallery without getting caught up on the tables. But I can tell you, even with 3 independent stations, that when you have 3 tables running, up to 15 students working, that can be pretty crazy, man. And people can trip over each other. So you really want to have some thought as to where things are and how things get laid out. Consider ample storage cabinets. So what we see here is you have something very similar to what we saw before, right? You have vents behind a sink in that case, which I find that interesting. But vents behind each one of the embalming machines, vents here at the bottom, so we can bring in more tables. But if you look at the chemicals, there is ample chemical up here for anything you would need, and it looks like they have some Dodge product right there. That looks like old Pierce labels to me. So chances are pretty good this might be a school that's showing off multiple different chemicals. I think that might be Frigid over here, some old Frigid bottles maybe, I don't know. And I can't tell who that is in the middle, maybe Champion or someone. Preparation room should not serve as your main storage room for all of these materials. You should have your boxes stored somewhere else. And most of the cabinets are 24 inches deep. Custom cabinets may be necessary. And pay attention to your OSHA requirements in your state for cabinetry. They may require certain minimum clearances between countertops and stuff like that. Table arrangements are limited only by the size and shape of the room, and the embalming station design creates one or more fully equipped operating areas within a larger area. Adjacent stations accommodate the seed and care procedures other than arterial embalming, and these separate stations are appointed with specific supplies needed for the function, such as cosmetic application, hairdressing, stuff like that. So if you look at the background of this photo, you can see that we have an embalming station right here. I don't know why I'm having this delay when I put my pen on the screen. We have an embalming station over here, right? And then over here, you can see that there is another table, but there's no embalming machine nearby. So, and I don't see any sort of nothing to indicate over here that there's a drain going into a flush sink, because you can see the flush sinks are right here. If you're wondering what those were, with those toilet-looking things, those are flush sinks. So that might be a dressing table. That might be strictly a dressing table, and chances are pretty good it's probably going to have a drain or something there, because then you can also use that as a third prep station if you need it. Another great example of stations right here. Flooring must be durable and easy to clean. Avoid materials that create a slipping hazard when wet. Generally speaking, we don't like to put mats down in the prep room because mats get really grody, like really, really grody, and you have to clean them constantly. So chances are pretty good that, let's go ahead and turn that off. At least I hope that's off now. Realistically, again, you don't want to put down mats if you don't have to, although some places do mats. They get disgusting over time. So disposing of them can also be problematic because of the fact that they are then contaminated. And disposing them in your general trash may not be a thing that you can do. Let me go ahead and put an end to that. I don't know how or why. Do not disturb. Blink. Epoxy coatings provide a seamless and non-slip surface that is easy to clean and disinfect. Epoxy can also be used to cover existing types of flooring. Epoxy is fairly popular. It can be pricey, but it's essentially a one-time thing. You drop the epoxy on there, you seal it, and it's done. Clay or ceramic tiles require grouting between the tiles. Grout is porous. It must be sealed before use. And avoid glazed tiles because that is slippery when wet. Vinyl tile is also seamless, resilient to cleaning products, and comfortable to stand on for hours at a time. You can either buy vinyl in pre-made squares or rectangles, or you can actually buy it in sheets and roll it all out so it's absolutely seamless. Paint. You can have a painted floor. A lot of people say, oh no, you can't have a painted... No, you can have a painted floor, okay? Paint is simply the cheapest and the most problematic because as you're scrubbing and buffing, the paint can the paint can wear out. So realistically, one, you need a paint that is going to resist spills, and two, you need something that's going to seal the underlying floor surface. So it's kind of the cheaper version of epoxy. My guess would be if you had the choice between this or epoxy, I would say go for the epoxy personally. Window selection is based on the location of the preparation room within the building. Privacy must always be ensured in the preparation room. Window glass cannot be transparent and allow visibility into a prep area. Growing up in the 80s, shopping malls were very dark places when the lights were off because there was no external lighting. If you go to any sort of modern shopping experience these days, shopping mall-wise, usually see tons of skylights, lots of natural lighting because it affects shoppers' moods. And the same can be said about prep rooms. Having adequate lighting is important. Having natural lighting is also a benefit. The problem is windows create liability hazards. And in a day where someone can go on to Temu and buy a drone for less than $10, that's a problem for you. Vented glass block installations allow privacy and, like conventional windows, allow incoming fresh air. There's no small way that you can arrange your prep rooms. And the type of glass options, again, work with a quality architect to determine something that is aesthetically nice and pleasing in case you want to show off and showcase your facilities, as well as functional and able to maintain privacy. Preparation room doors must be secured to deny access to unauthorized persons. Conventional locks require keys. Touchpad locking devices require only a code, and code can be readily changed when the need arises. So controlling access is outside the purview of this course, but realistically, if you're going to be using key card, key fob, or numeric access, you need to make sure people aren't sharing their numbers and you are treating this like you need to for security purposes. A conventional door opening is only 30 inches wide. It's only 30 inches wide. You need something wider than that. So 36-inch width is mandatory in many localities to accommodate caskets, mortuary equipment, and stretchers. And something that's very important, okay, is if you have a narrow hallway, you need to figure out when you are coming through, can you make a curve with your casket, or you're going to be taking skin off your knuckles because your caskets are going to hit walls. So having the proper type of door is important, 36-inch wide minimum. Also, do you have clearance through that door to be able to comfortably move equipment and merchandise? Ceilings and walls, material selected should be impervious and able to be kept clean and sanitary, while material must be wipeable and readily disinfected upon contamination or soiling. Wall material must be wipeable and readily disinfected. Gotta love speech recognition. Some materials for walls include glazed masonry block, ceramic tile, and impervious wall boards and paints. Sound insulation should not be overlooked. So many old school funeral homes did not have any sort of sound insulation, have really inexpensive doors leading into other rooms, and you can hear everything that goes on. You really don't want people hearing anything in the prep room. And you might say, well, we're going to take away the prep room and put it into something new. You don't want people hearing private conversations in the office, talking about sensitive things on phones, stuff of that nature. So even when you're considering a prep room, anticipate maybe what might happen if you repurpose your prep room into another room. You want as much privacy as possible. Special density cellulose fiber structural board can be used to lessen sound transmission. There are YouTube videos you can watch of how to basically jury rig a soundproof area without a whole lot of renovation or any renovation, just by buying products on like Amazon. Do not omit soundproofing. OSHA regulations address emergency shower and eye wash station requirements. The general requirement is applicable to all facilities that require the installation of emergency shower or eye wash stations equipment as a form of first aid. You need one of these in your prep room. So you need to have a drench shower, you need to have an eye wash station, plain and simple. Sufficient water pressure is necessary for the proper functioning of hydroaspirators as well as other equipment in the prep room. So you want to make sure that you're using the proper size piping, hosing, all sorts of stuff. We had a remodel of my prep room in my former employer, and the hydroaspirators weren't working. You would turn them on and they would spout water like a faucet out the front. Could not figure out why it was, and ended up calling the architects. Took the phone, took pictures of inside the stations, and sent it to them and say, "Oh, I can see what your problem is. You got the wrong hoses on there." They had installed hoses like you would install on a faucet in your kitchen. And those hoses are not sufficient to allow enough water to pass through to create the vacuum necessary. So, had to call the contractors back out. They said we built it to spec. They didn't build it to spec because they didn't even look at the spec sheets that were sent. They were still taped inside the drawers of the stations they installed, so there's no way they looked at them. And that stupidity essentially stopped a $35,000 workstation, all because of one $10 kitchen hose. So it is really important to make sure that when you're installing your equipment that they are meeting the requirements of the equipment so it can function properly. Low water pressure reduces suction, and small supply lines and older galvanized pipes are often the cause of this low pressure, which means you may have to have alternative or mechanically assistive vacuum devices. Wastewater disposal must be in compliance with code to prevent health risks. This is typically not something very large that we have to deal with in the prep room, but if you have an alkaline hydrolysis machine, more than likely you're going to have conversation about wastewater disposal. Backflow prevention is extremely important in your prep room. Backflow is the reverse flow of liquids within a system caused by siphonage and pressure variables. Siphonage is created by a vacuum or partial vacuum in the water supply system, and siphonage is also caused by ordinary gravity. There are plenty of videos on YouTube that will show people doing physics experiments and running hoses and using gravity to make water do really crazy things. Okay, now imagine that's contaminated with other potentially infectious material, blood, formaldehyde, preservative. You really don't want them flowing in your water fountains. A device called a backflow preventer is a one-way valve installed in the water supply line that serves the facility. Subpart J of the Occupational Safety and Health Act pertains to general environmental controls, and it states construction of non-potable water systems carrying any other non-potable substance shall be such as to prevent the backflow or back siphonage into the potable water system. So here's an example of a hydroaspirator with a vacuum breaker. You see at the top, let's get the old pen working over here. Here is your hydroaspirator, and it is connected to backflow preventer likely up there. And, or I'm sorry, no backflow preventer up there, but a backflow preventer here. Because as the stuff comes in, it's going to come out here. Should this ever fill up and start to overwhelm, it's going to shut off. So that way nothing gets pulled into the faucet unit, which can then drift and contaminate throughout the rest of the funeral home. It's also why whatever feed line is coming into this unit also probably has a backflow preventer on it hidden. The hydro aspirator is attached to a water faucet over a flush sink. A clear plastic hose connects to the aspirator and the trocar. So there is where it would connect to your vinyl tubing would connect to the hydro aspirator, and this would then run into your trocar. Really clear plastic hose is the best, so that way you can see the materials that are being aspirated, if it's liquid, if it's solids, what type of solid, stuff of that nature. A lever on the aspirator directs the flow of water, and we don't see it in this picture, but it is probably right on the other side of this thing, and it works exactly as you would imagine. If you pull it perpendicular, it shuts off the unit and causes water to flow out the nearest hole. If you put it in the upright position parallel to the pipe, it's what causes things to go through. So again, when the lever is inline or vertical or parallel with the unit, water flows from the unit into the hose. When the lever is horizontal, suction is created within the hose for aspiration. Again, this is probably going to rely on some orientation. Just be aware that no matter, well, when they ask on a board or a test question, they're going to follow what it says here. If it's inline or vertical, it'll flow into the hose because it is blocking. When the lever is horizontal, suction is created. Moral of the story, when you're using these things, you always attach everything, put your hose or put your trocar down the drain, and then turn on your hydro aspirator. That way, if there are any blockages or anything, if water starts spewing out, it'll spew into the drain, and then you can make adjustments to either the hydro aspirator or check for clogs or other things. Whoops. Placement of the hydro aspirator is important for proper functioning. The device attaches to the faucet approximately 2 inches above the sink rim and discharge hose situated below the room to contain effluent. Large diameter clear tubing is attached so the embalmer can readily see the materials being aspirated in cases of purge. Visual inspection allows the embalmer to determine the source of the purge. Now, don't be surprised if on some units you're going to see that it is not vinyl hosing, it is just straight pipe. So in my units at my former employer, at the bottom of the hydro aspirator, you wouldn't see something like this. What you would see is a straight pipe that goes down into the sewer system. This is what we would see actually on the table and only on the table. If you have issues with smaller pipes, you may need to use an electric aspirator. These things are extremely heavy. The electric aspirating device requires electricity, which means if your power's off, this is off and you can't do anything. It is a freestanding device. It's commonly selected where low pressure is an issue. You can see you hook hoses up over here to the side. And that's basically it. This is your suction hose. This is where your trocar goes, and D is your discharge. This is where the stuff flows out, and you'd run a tube from there down to the sink. Or to the drain, more appropriately, the flush sink or drain. Code compliance may require hot and cold water in the prep room. You absolutely want hot and cold water in your prep room, one for hand washing and hygiene purposes, also for later on when we study how chemical works. Warm water accelerates a preservative reaction, cold water slows it down. A minimum temperature of 130 degrees or 145 degrees Fahrenheit may also be enforced, again, for sanitary purposes. And OSHA requires that all hot and steam pipes be insulated when employee contact with the pipes is probable. This is especially true and especially important if you have a prep room in a basement where the pipes are completely exposed. Best practice would be to take any of those pipes and hide them behind cabinetry or something else so that there's no unwanted contact. Convenient water service to the embalming table. The machine and sinks create efficiency in the work environment so that you are not walking across the room to turn water on and off. Water can be supplied directly from service sinks or from overhead. Very common in some prep rooms that your sinks actually come down from the ceiling, so that way there's no obstruction on the floor. That is something that is out there. And when the table is permanently installed, a supply line can be hidden inside the table, can be hidden inside of a station. It's really your call. There are many different types of sinks for selecting a waste sink. So here at the top, you have an example where you have a flush sink, and this flows off the table down the drain into the flush sink. You can see that there is a vent right here to pull fumes in and away. You also would want to take plastic wrap and cover the top except for where the hose actually comes into the sink to minimize any sort of ridiculousness floating up into the room. If you look closely, you can see some vinyl hosing over here. Chances are pretty good that that is your hydro aspirator attached somewhere to the left of the pipes. And you can see when it's done, it really is just a toilet without a lid. There's your flush handle. You push it, and it will take care of things for you. Flushable basins or wall-mounted installations are customary, and you have something like this over here. This is what I had in my old employer's room. Not so much a flush sink as it is just a receptacle going into a pipe. So you have a pipe that's in here, and it flows down into your room discharge. And what you do is you turn the valve. The valve starts water running, so it creates basically water going down the drain. And what this is right here with the little handle, that's actually a filter on the drain. So if something large happens to come off the table, whether it's hair, whether it's personal effects, whatever it might be, it won't go into the drain. It'll get caught there. Those get extremely disgusting. Really, really nasty. Hand sinks should be located conveniently for the embalmer to wash hands between glove changes. Touchless faucets may be installed to avoid handling of faucet controls. So you could have sensors, you could have foot pedals, your call. Controls for knee and foot operation are available, as well as elbow or forearm operation. Ventilation. So plumbing and ventilation, as we learned last chapter, are extremely important in the prep room. So now we move on to ventilation. Adequate room ventilation is essential. Preparation room ventilation requirements are determined by the size of the room. A number of states have adopted 12 to 20 air exchanges per hour for an average-sized embalming room. Remember that the NFDA recommends 15 to 20 air exchanges per hour. 12 to 20 is essentially a happy number, and the minimum OSHA is 6. So NFDA and recommended numbers are double what OSHA permits. The levels at which serious inflammation due to formaldehyde exposure of the bronchi and lower respiratory tract would occur in humans is unknown, because every person kind of handles it differently. Last lecture, we learned that formaldehyde has different levels. Up to 2 parts per million, expect some, unpleasantness. 2 parts to 5 parts, there's more stuff that goes on. 25 to 30, you're having serious problems. And 100 parts per million is immediately dangerous to life. So the levels at which you are going to respond is realistically unknown. It could happen at any one of those levels depending on who you are, which is why you're given those ranges. Inhalation of high levels, however, has caused chemical pneumonitis, pulmonary edema, and death. Chemical pneumonitis is also known as embalmer's pneumonia. Engineering technology and thought in the design and construction of preparation rooms reflect the recognition that because formaldehyde is heavier than air, exhaust tips located at or near floor level, when combined with the introduction of uncontaminated air from the ceiling level, are an efficient method of ventilation. Such systems have the added advantage of drawing fumes and contaminants down and away from the operator during the embalming procedure. And the key to creation of an embalming environment protective of the embalmer's health and comfort is airflow and adequacy of ventilation. Generally, these are also climate controlled, so the more air that pumps in, the more likely you are to have a steady temperature. The number and location of windows and doors are components of the total ventilation system. Remember we talked about the formaldehyde rule. If you add a door, you add a window, you lose a door, you lose a window, that changes how the ventilation in the room works. So you need to do an air quality test to determine that it is still sufficient. Cross ventilation requires windows or intakes on opposite walls. In choosing the location of the exhaust, care should be taken so that the air flows away from the operator. The grill on the exhaust fan and on all other grills should be removable for easy cleaning. If we go back and we look at the different vents that we were looking at, all of the grills are just screwed into place, so you can unscrew them or unlatch them, pull them off, wipe them down on both sides, and then replace them. There are many different air conditioning units to choose from. When the entire funeral home is air conditioned by the same unit, independent controls are installed in the prep room. The prep room should always be separate from everything else in your funeral home, so that way you can control the temperature in the prep room independent of anywhere else in the funeral home. Separate controls help to compensate for ventilation, which impacts climate more drastically in this location compared to the remainder of the facility. So prep room equipment. Deep breath. We have talked at this point about how to design a prep room, what features should be in a prep room, what materials you should be using. Now we're going to talk about stuff that's actually in there. So the first thing is you may have mortuary refrigeration. Some prep rooms have the refrigeration in other areas. Some have large industrial rooms that are refrigerated. Some have maybe a two-person wheelable morgue. Every funeral home, every central prep is going to be different. Refrigeration units are more commonplace in funeral homes, and many states require refrigeration as a matter of law, period. The purpose of cooling units is to slow post-mortem changes in the deceased body. Maximum temperature for cooling units is determined by state law. Minimum temperature should remain above freezing. Generally, it's somewhere between 36 and like 40 degrees is where they want it. You do not want to go to freezing, because when you start freezing bodies, that creates embalming complications that we're going to study later in the course. Access to the area containing the cooling unit must be locked by key or touchpad. Fancy way of saying your morgues should be as secure as your prep rooms, especially if they are freestanding. And just because they're in a prep room that is already locked or is basically access controlled, your morgues should also be access controlled so that people can't just go in there and open them up readily. If someone gains access to the prep room, they're going to have to take more steps to gain access to the actual refrigeration unit. An entry-exit log is kept for decedent stored in the unit. This is something very important here, folks. Okay? This is something very important. All of your morgues should have an entry log, so you know who is in there, who is somewhere else, etc. So this is something different than the main whiteboard that many funeral homes have, which have all the names of all the people and all the services, etc. We are strictly looking at an access log, so you know exactly who is in refrigeration, who is not in refrigeration, and where they went when they were taken out. So that way you can just walk up to the morgue, look to see that if a person is still in there, or if they've been transported to another area of the facility or a different facility for services. ID tags or bands are attached to the body and to the body bag. Identification of remains is extraordinarily important. Many states have multiple stages at which you must apply identification to the body or the containers that the body is in. Obey those laws. Double check your ID tags consistently when you are in practice. Human remains need to be positioned in a supine position, lying face upwards with shoulders and head elevated. So what you see here is not appropriate for funeral service, because this person is lying completely flat. And what is happening is all the fluid in the chest is going to start flowing into the head, and it is going to cause swelling of the dependent tissues. You want the head more elevated so that fluid drains into the chest, where it's more easily controlled during aspiration. This, of course, can get very challenging based on the size of the body, etc. A maintenance cleaning schedule is necessary to document sanitation of the cooling unit. Lifting devices are essential for heavy lifting and for use by a single operator. Floor lifts are manually operated. Floor lifts are manually operated, and many of these are hydraulic. Ceiling hoists require electricity for operation. These things can be dated, so there's a finite service life for them where components are no longer available. Many require a lead-acid battery of some sort that maybe like goes into a motorcycle in the event you have a power shortage. Both devices have safe operation limits for weight. So if you are dealing with people that are extraordinarily obese, 500, 700 pounds, probably a ceiling lift is not going to be sufficient for you. Whatever those weight limits are, obey them. Okay, obey them. Flexible polyethylene body transfer boards are strong, non-absorbent, and easily cleaned. Sometimes these are called slide boards. Placed beneath the body, transfer boards are used to move the remains from the mortuary cot to the preparation room table and other surfaces such as dressing tables and trays. Again, they just facilitate the body going left and right on and off the cot. They can also be somewhat useful for getting a body onto a cot. There are different types of transfer boards out there. Many people are familiar with the ones you see EMTs use. Okay, again, those are polyethylene as well. The problem is they are very rigid. They are intended to lock a person in place and allow that person to be placed on a cot or into a transport vehicle. These boards are not intended to have that type of rigidity. They're somewhat flexible. Okay, you can't fold them like a sandwich in half, but you can get them pretty close to each other. So you would not want to get a body on there and then try to pick it up because it's going to sag right in the middle. Is it better than just grabbing arms and feet and then trying to carry it somewhere? Probably, absolutely. But ultimately, this is not intended for that purpose. Instead, you're looking at a body transfer board for something like that. This is the rigid one. Sometimes these are foldable, but a body transfer board is typically extraordinarily rigid so that you can actually carry the body on it without too much difficulty. Now, there's bunches of different types of tables out there. Some are stainless steel, some are porcelain coated. Most of these, or all of these, are actually stain resistant because of the different types of chemicals and organic materials that get on the body. Some tables are portable. Some tables are fixed in location. Some have manual adjustments. Some have hydraulic adjustments. There is a wide variety of things out there. Get what you can according to what your budget provides. Body bridges can be used to elevate the body above the table, and drainage is easily flushed away from the body and from the body and the embalmer. And you can see that all these embalming tables have one thing in common. They have these little grooves on the side, and the goal is water continually flows down these grooves, and anything that falls on there disappears. It goes down the drain and it's gone. That's really the key feature to an embalming table. It cannot just be flat, and if you have a body on bridges, which you can see an example of a large body bridge here. This keeps the body completely off the table, allows for fluid to go under the body, nothing sticks to it, makes it very sanitary when doing a prep. After embalming, the body may be transferred from the embalming table to a dressing table or your storage room. Dressing tables may be entirely stainless. They may be folding like you see here. Dressing tables are unsuitable for embalming. And the way you can easily tell a dressing table from an embalming table is there is no drain hole. Now, this doesn't mean that you cannot use an old embalming table as a dressing table. It just means that if you are looking at purchasing a dressing table, do not expect to find any holes at the bottom of it. Most arterial embalming is done using electric machines. There are also some historical methods we will touch on. Some of the historical methods are still used when the power goes out because they rely on gravity. So the 6 devices we're going to look at are gravity percolator, the bulb syringe, combination percolator and bulb syringe, hand pump, air pressure machine, and the centrifugal pump. So first up, we have the gravity percolator. Arterial solution is poured into a large glass reservoir called a percolator. These days they're made out of plastic. It has a delivery hose attached to it, like you see here. And then the hose is attached to the body. And you can see that this is adjustable. So you want to raise these things as high as possible because gravity is going to create pressure, which then comes and forces the fluid into the hose. The percolator is elevated above the body to create pressure necessary in the delivery hose to allow the embalming solution to flow into the arterial system. This works extremely well. It's just slow, very slow. Approximately ½ pound of pressure is obtained for each foot of height the device is raised above the injection point. Very important number, okay? Very important number. ½ pound of pressure for each foot of height above the injection point. For every 28 inches of height, 1 pound of pressure is created, okay? For every 28 inches of height, 1 pound of pressure is created. Because of ceiling height restrictions in most preparation rooms, pressure is limited with gravity injection. Maybe you get 2 pounds of pressure. Realistically, this is limited to power shortages and bodies that are going to be used for anatomical donation, where they will hook them up after initial preservation and then do gravity embalming and immersion over time, usually a month or so, for a thorough saturation. Gravity embalming provides a slow, steady method of injection that allows the body to accept the embalming solution at a lower rate, which means if it's accepting at a lower rate, you have to do it for longer in order to get thorough preservation. Let's talk about this in food terms that everyone can understand, okay? If you are going to marinate meat, the longer it stays in the marinade, the more thorough the marinade becomes, right? Just penetrates better. Yeah, I know you have to poke holes and all of that, but let's assume for the sake of argument, you could just drop it in there and it would marinate. The longer it's in there, the more thorough the marination. This also leads to a greater volume of the arterial solution being retained by the body tissues, i.e., it stays preserved longer. The bulb syringe is a handheld device. It consists of a rubber bulb with hoses attached at either end. A one-way valve in the device allows for this pump to operate. One hose is placed into a container, and the embalming solution flows into the bulb when the device is relaxed. Once the bulb is full, squeezing the bulb forces the arterial solution into the delivery hose and the body. So what's the fun part about this? One, as this stuff comes in, it's going into the bulb, it's filling here. Then as you squeeze again, it pushes it out the hose. Problem is, you don't know really how hard you're pushing. It becomes harder as you go because the body then starts filling with fluid and you have to push all the fluid ahead of it out of the way. And you're doing this by hand for a long period of time. So you can imagine that this is going to be exhausting. Some genius came up with the idea, let's hook one of those things up, the bulb syringe, to a percolator. And let's hook one of these things up to a percolator. And what they came up with was a device that utilized gravity, and when you had to give it that extra oomph, you're able to give it what you need with the device. So you have a steady amount of pressure pushing down from gravity, and then you can squeeze when you need it. I mean, you still have to do it because it's a one-way valve on the bulb syringe, but at least you have that pressure also pushing down. It's not going to be as hard. Eventually, they came out with the hand pump. So the hand pump has 2 hubs into which hoses can be attached. One hub delivers air to create pressure, and the other one creates a vacuum. Arterial fluid does not flow through the hand pump. So bulb syringes, it goes completely through it. Hand pumps, they do not. So what is happening here? Okay, let's look at the hand pump. Here you have, let's get the pen working, hub number 1, hub number 2. This is your vacuum pump, and this is your pressure. So this is essentially sucking in air, and this is pushing air out. Okay? So what you would do is you would have a jar, and you would have your hand pump. So here's our liquid, and you could either have aspirate or body, okay? And what would happen is you would place a hose into the liquid, you would place a hose into the body. And when you pull the thing up, it would, I'm sorry, wrong idea. Wrong idea. Here's your hand pump. Here's your ports. Here is your jar. Here's the hose going into the body. Here's the hose hooking up to the jar. As you push pressure into the liquid, it pushes it through the hose into the body. Nothing ever goes into the hand pump. Nothing ever goes into the hand pump. Okay? So you pull up, air goes in over here. Then you push down, air comes out over here into the jar, pushing the liquid into the body. What's the problem? You could push air into the body, and that causes problems. To aspirate the body, you do the exact opposite thing. You take the hand pump, right? You have the jar. You have your trocar into the body. And now you hook it up to the other side. And when you pull the lever up, it pulls particulate into the jar. It pulls particulate into the jar. These became the rudimentary apparatus, which we know today as electric embalming machines. You have to be careful with these machines that you do not pump air into the body. An air embolus creates flow problems. There are tons of videos on YouTube about why air in pipes is an issue in your home, and the same principle applies in a much smaller scale into the body. A bubble is an obstacle, and once it lodges someplace and creates pressure, chances are good you're not going to get liquid past it worth a squat. And you have no way of getting that air out because you have no way of making a hole where that air is and forcing it out. Once you make that hole, fluid is then going to leak from the hole. So we talked about this already. If you need to pull aspirate out of the body, you simply put it on the other hub. Neither fluid nor aspirated contents go into the pump itself. Everything goes into the jar. So modern machines are basically centrifugal pump machines. Okay, centrifugal pump machines. Many of these have large volume tanks. Some of the smaller ones, the Porter Boys, might do 1.5 gallons to 2 gallons. The larger machines, the Duotronics, the Dodges, the Frigids, they do anywhere between 3 and 4 gallons. There are larger machines than that even. So with a motorized pump, a constant preset pressure can be maintained in addition to the preset rate of flow of the arterial solution into the body. So we're going to be talking about rate of flow and pressure later. They are two separate concepts, very important concepts that you understand and master. Okay? If you understand how rate of flow and pressure works, trust me, embalming is demystified. It is always recommended that you set your pressure prior to arterial injection, because then you can control your rate of flow accordingly. The rate of flow can be determined once the arterial injection begins. Pressure is how hard the fluid is being pushed. The flow is how much is going at any given time. So for instance, you can have a very slow rate of flow with a lot of water pressure and stand just completely fine as the water is pushing around you. But if you have a fast rate of flow, low pressure, might push you down, but you can probably get back up relatively easy. If you have a slow rate of flow with high pressure, it might not push you down, but it can probably injure you by bruising you or cutting you because the pressure is high, but the rate of flow is small. And if you have high pressure, high rate of flow, you basically have a water cannon just throwing you down the street. Now, historically, there was something called an air pressure machine. And what the air pressure machine did is it took the same concept as the hand pump, but then attached an electric pump to it. So, with centrifugal pumps, you actually put the fluid into the machine, and then the machine puts it into the pipes and then pushes it under pressure out of the unit. With an air pump machine, you actually put the liquid into the jar, and then the machine pushes air into the jar, which then pushes it out into the body. It's the same concept as the hand pump. It's the same concept as a hand pump. The difference is these units need to be very, 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 very strongly sealed. So why all of these glass jars that are used have these really thick pressurized lids. It's basically a one pot. It is a pressure cooker. And you do not want this thing to break in any way, shape, or form. These devices are very dangerous, and pressures must be carefully observed. Some of these machines can produce pressures and vacuums of up to 30 psi. And at 30 psi, if glass breaks, it's going to be bad for anyone standing next to it. So air pressure is still used in some areas of the world, Asia, Great Britain, most of Europe. Again, not a very safe thing compared to the centrifugal pumps, but it is still being used. Air pressure embalming machines require electricity only temporarily. When the pressure is created within the machine, the power is turned off. So once you have basically filled the air reservoir with your pressure, you can then unplug the machine and forget about it, because the air pressure is being stored in the reservoir. So this is the advantage of it. You can turn these things on, it builds the pressure, it stores it in the tank, and then when you finally have to hook it up and open it up, that's when the pressure starts coming out. Again, it is identical process to the hand pump, with the exception that, or no exception, it's identical to the hand pump, period. During embalming, it may become necessary to reset pressure and rate of flow to establish good distribution of the embalming solution. Yeah, things can start off pretty well, but as the body starts filling with liquid, you have to push a little bit harder. So you might need to increase your pressure, but leave your rate of flow the same. Pressure ranges in the motorized force pump can be very great, with some machines capable of producing up to 200 pounds of pressure. Some people might say, oh my God, you never have to use that level of pressure. You probably don't, but you can get great results with 100 to 120 pounds of pressure, providing you understand how that is affected by your rate of flow. I like doing high pressure, low rate of flow embalming. In fact, I think it's probably the best way you can embalm. In some machines, the motorized centrifugal pump runs at a constant speed. In others, the speed can be variable. And yet in other machines, two separate motors operating at different speeds are available. Everyone does something a little bit different. Many of the modern machines also provide for pulsation, where it spurts, just like your heart does, which more naturally mimics fluid pushing through your vasculature, distributing and then diffusing. So let's talk about pressure. Pressure is the force required to distribute the embalming solution throughout the body, and it is measured in pounds per square inch, PSI. Okay? Rate of flow is the amount of embalming solution that enters the body in a given period and is measured in ounces per minute. Pressure, the force required to distribute the solution, measured in PSI. Rate of flow, the amount of embalming solution entering in a certain period, measured in ounces per minute. They are two different things. Two different things. So potential pressure. I have my machine, I turn my machine on, and the machine tells me it is 15, like it says here, 15 pounds per square inch. This is potential pressure. Nothing is flowing right now. Nothing is flowing right now. But the machine is telling me that it is operating at 15 psi. So my rate of flow valve is closed, nothing is flowing, and this is the potential pressure that I have to push fluid into the body. Actual pressure is the reading on the pressure gauge when I open my rate of flow valve and fluid is being delivered to the body. Okay? So this was flow is closed, nothing flowing. I open the valve, fluid is now flowing. And what happened is this dropped by 5 psi. And this is known as differential pressure. This is the difference between the potential pressure and the actual pressure reading, and is an indicator of rate of flow. Why is this important? It's simple. I turn on my machine, nothing is flowing. I open my rate of flow valve, nothing happens. There is no change in my pressure. That tells you nothing is flowing. Period. It tells you nothing is flowing. Because the moment you open the hose, what it should be doing is you have a loss of pressure because fluid is now moving somewhere. So that is your clue that when you open the rate of flow and nothing happens, you turn your machine off, you check all of your hose connections to make sure that everything is linked up, especially if you're using quick releases. Then you turn your machine back on, set your pressure, open your rate of flow, see if it drops. If it still doesn't, now you have to check for blocks and all sorts of other problems. Some machines will have a flow rate or a rate of flow gauge. These can be added to some machines. It's a value-added option. These can be very important. Okay, I find looking at my rate of flow is very useful for me as an embalmer. Not just the fact that I know it's going in, but how fast it is going in. Not that there's a drop in pressure, but exactly how much is flowing at one given time. There's been much misunderstanding in regard to the pressure that may exist in the body as a result of the injection of a solution. The fact that a pressure gauge reading on the embalming machine indicates a given pressure at which the fluid is leaving the delivery hose does not mean that that is the pressure that exists within the body. Fancy way of saying, okay? You have the machine set at 100 psi. Fluid is exiting the machine at 100 psi. It is not entering the body at 100 psi. Okay, it is not entering the body at 100 psi because you're controlling rate of flow, and by the time it gets to the entry point, the pressure has changed. Still pushing pretty hard, but rate of flow matters. Now, we're going to see later, not in this chapter, but when we study the vasculature. You have arteries, okay, you have arteries that become arterioles, and then after the arterioles, they may go into capillaries and then venules, or they may go from arteriole to venule and then to vein. But the moral of the story is, at some point, the pipes get so small, then they open back up again. And the problem is, all the pressure builds up here, but when it gets to this point, the pressure is now normalized. The pressure is now normalized. And once it flows through and starts coming into the open area, the pressure is constant. The pressure is constant. And we're going to see that drainage will always have a fixed pressure. This is why you can increase your pressure as much as you want. Your exiting drainage is likely not going to be affected very much by what you're adjusting. We'll talk more about that later in the course. You'll get a better grasp of why that is and why you really don't want to push too hard or flow too quick, because that can make life absolutely miserable for you as the professional embalmer. Now, deep breath. Deep breath. We're done looking at equipment. We're done looking at equipment. We're now going to look at instrumentation, the stuff that we use as embalmers. An embalming chemical supply catalog lists many instruments, many of which come in a variety of sizes and modifications. Embalming is not performed under sterile conditions. Instruments can be reused throughout the embalming process. It's not a one-and-done concept. Okay? It is not a one-and-done concept. Most instruments are made of stainless steel, plated with nickel or chrome for protection against rust or chemical agents. Instruments are chemically treated to be heat-resistant and durable. Always make sure an instrument is okay to go in an autoclave before putting it in there. That's especially true with older equipment like bone separators or glazed wood, because an autoclave will take that material right off. So general equipment. Aneurysm hooks and needles are curved-tipped instruments chiefly used for the blunt dissection of tissues to locate and raise arteries and veins. A feature of the aneurysm needle, okay, is that there is an eye through which a ligature can be placed to allow it to be placed under a vessel. So if you look closely right here, you can see there's that little black hole. Same thing up there. This actually doesn't have a hole. This actually has an open slit. And you'll see that these have no holes whatsoever. So these are hooks. And these three for sure. And this likely has a hole in it because I've never seen one of these without one. These are needles. That is the only difference. And over here, this is basically a dental pick. It would be considered an aneurysm hook by our standards. This actually isn't a needle. This is a... I forget what the heck this is called. This is going to be used basically to protract or retract tissues. This is actually way too large for what we would be using it for. So realistically, I wouldn't say this is a needle at all. That's just something that you would use to grab tissue to separate and hold it open. So hooks and needles. These instruments are useful during feature setting to lift eyelids for insertion of an eye cap, separate lips to help position dentures. Hooks and needles have a tremendous number of usages. They're not just good for raising vessels. And over time, through your internship or apprenticeship, your residency, whatever they call it, you will see the different uses that we have for this instrument. A bistoury knife is a curved cutting instrument designed for blunt dissection. It is customarily used to open arteries and veins and to work in areas where there are sensitive things to carve away tissue that you don't need. And what makes these important is the cutting edge is right here. Okay, this is the actual sharp edge of the bistoury knife, the inside edge. So you can place this in an incision, and some of these also have a blunt tip so that you can position it and then cut away with what you need. Me personally, I have never used a bistoury knife at all in any clinical setting, not in professional setting. I'm not a particular fan, if we will, of bistoury knives. We have hemostats or locking forceps. A wide variety of hemostats are available. Hemostat can be used to clamp leaking vessels. They can be used to grab things. These are fairly useful instruments, and you should have a bunch of these in different sizes to accommodate different things. So an arterial hemostat is used to hold an arterial tube securely in an artery. We put an arterial tube into an artery. We take our locking hemostat, our arterial hemostat, and then we clamp it over that to hold it in place. We also have another arterial hemostat right here, and you can see that that has holes as well. The ends of hemostats may be curved or straight, serrated or smooth, plain or rat-toothed. Again, they all do different things. So a serrated hemostat allows you to grab and hold better. A smooth one, not so much. Rat teeth really grab because they have 3 sharp points, 1 on the bottom, 2 on the top, and they're meant to really grab something and hold on to it. So they can be very useful for grabbing loose flaps of tissue, stuff of that nature. Plain front, you might have serration with the plain front. That just allows you to grab something like clothing and then pull it. There are so many different uses for locking forceps. Now, the only difference between a standard forcep and a locking forcep is the lock. If you get rid of this, you now have a standard forcep. That is the only difference. So instead of grabbing it, locking it in place, and then pulling, you actually have to sit there and use your fingers to hold it shut while you're doing whatever you're doing. They each have their uses. Dressing or packing forceps are very long hemostats used for packing orifices or handling contaminated bandage dressings. Again, the goal here is this is a fairly large one to grab material. Typically, we only use that in funeral service for either pulling clothing up around people, or for taking cotton and putting it into places in the body, which we'll talk more about as we progress through the course. Scalpels are sharp cutting instruments used for making incisions. We can excise tissue with scalpels, but realistically, on a normal case, we're making incisions and we put it down. In my labs, when I taught my labs, the only thing we used a scalpel for was making incisions. That's it. Disposable scalpels are best practice to reduce the risk of injury during blade replacement. You can see here on the right-hand side that this is a permanent scalpel. You have to keep that sharp. No ifs, ands, or buts. That is all one piece of metal. On this one, that's a disposable blade. This is a disposable blade. You can see the locking mechanism there. Same thing over here. I assume this is a fixed one as well. I don't think you can pull that tip out. So if these become rusted and pitted, you're going to have to throw the entire unit away. With these, you just throw away the blade, and the handles pretty much can last forever with good care. Retractable blade scalpels nearly eliminate risk of poking things you shouldn't. The blade retracts into the handle after use, and non-disposable scalpels require blade replacement. Typically, those are one-and-done solutions, so you can use them for one case, maybe two, and then you throw them out. There are some scalpels out there called pen blades. I really like pen blades. You can use a pen blade for about 2 or 3 cases before you finally have to dispose of it. They are retractable. I always have pen blades in my crash kit for embalming. OSHA requires a sharps container for the disposal of all sharpened contaminated items, scalpels, needles, wires, things of that nature. The opening prevents reaching in for retrieval after disposal. And here's an example of sharps containers on the market. They also have a lockable lid, so at some point you close it and you can't get into it anymore. Scissors. Surgical scissors are used for cutting. Scissors can also be used to open arteries and veins. Me, personally, I always used scissors for opening my veins. I am not a big fan of using scalpels to do so. The first type of scissors we look at here are called arterial scissors. You can see they are very, very small, and they're used exclusively for basically opening vessels. They're not useful for most anything else because they are so small. There are arterial scissors that also have a very, very small front, but they come at an angle, something like this, look like kind of a foot. They are both considered arterial scissors. These also work fairly well with cutting wires. So these are probably not that thick on the blades, but the angled ones, those angled ones absolutely have thicker blades. It can cut through heavier objects. Plain scissors, you see here, you can see these have a little bit more depth on the tips. They're not as short. That's fine. They can be straight, curved, pointed, blunt. They can be combinations. Scissors are scissors, and they can be used for any variety of things. That being said, there is something out there called a bandage scissor. These are designed to cut bandages. They also come in a couple variations, but ultimately what their design feature is you have this tip at the bottom that slides under a bandage. You have a blunt tip on top, and they cut down and they just cut right through. That paddle shape is really indicative of a bandage scissor. You usually see these also on trauma shears. Separators, also known as bone separators in older textbooks because they were made out of bone. They can be made out of rubber. They can be made out of wood. The wood is usually glazed. Don't put that in an autoclave because it'll melt the glaze off. The only purpose that a separator has is to keep a vessel raised while you try to get ligature and stuff under it. I'm not going to say that people don't go hunting down separators, but realistically, if you go back and look at the aneurysm hooks and the needles, the separator is built right in. It is on the handle. I would not use the handle of a scalpel for something like that. But you can see, you can take any one of these, slide it under an artery, and you have a separator right there. And most of these are engineered for that purpose. You can see the ridges here. You can see the dip there, a ridge here, ridges here. So you slide it under and you have space to actually weasel something through, making it easier to pass through. Again, I'm not saying people don't use them. If it was me, I'm typically going to only keep maybe 1 or 2 separators on hand for emergencies. I'm just going to use aneurysm hooks and needles to keep my things high. So that is a professional point of use. For testing purposes, separators exist. They keep things elevated. Not much use for them otherwise. Now, suture needles, everyone has their own preference as to what needles they like to use for different suturing. This comes down to preference. It also comes down to purpose of what you're using, where it is you're trying to suture and what is you're trying to accomplish. So half-curved needles are predominantly straight and designed with a slightly curved cutting tip. A large one like this would be useful for closing autopsies or large incisions, absolutely. Smaller ones like this would be for more fine suturing, because as they get smaller, the more fine ligature you would end up using. Me personally, I am not a fan of half-curved needles. I'm just not used to using them. Double curved are my go-to for just about anything. They resemble the letter S. These are also known as autopsy needles. Again, you can get these in fairly small sizes as well. So if you wanted to do some fine suturing with a double curved, you are capable of doing that. Circle needles resemble the letter C. These are good for suturing with instruments. Okay, so if you are trying to get good at using instruments like a surgeon does, you would probably want to be using half circle, and these also come in a variety of sizes. Loop-tip needles, or half-curved loop-tip needles, have an angular grip. They're just like a single curve, except they have this angle at the end, which allows for better gripping. Again, you could use these for instrument suturing as well. Very, very good. I've had more practice with these, and I'm comfortable using them. And you can get them in very, 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 very fine, smaller needles. Some have a spring eye to make threading easier. Take the thread, you push it up against the groove, and it just kind of flows right through the hole. Spring forceps, another extremely useful instrument. The limbs of the forceps may be straight, curved, or angular. Tips may be smooth, serrated, or rat-toothed. The big difference between spring forceps and locking forceps is these always have a constant tension, right? If you squeeze it shut, it's going to want to open back up. So it's useful so you don't have to sit there and try to open and close with your hands, or when you close and lock, you don't have to undo it. So really, spring forceps are essentially tweezers. Angular spring forceps are used as drainage devices and usually called drainage forceps. You see an example of it right here. That would be an angular spring forcep. These come in a variety of sizes and shapes as well. So if you open up a catalog from your funeral supply company, you're probably going to notice there's a bunch of different things in there. Most embalmers use several types and lengths of spring forceps. I have a variety of sizes in my crash kit that I use. Surgical retractors are designed for grasping, retaining, or holding back tissues. Retractors and incision spreaders are used for embalming purposes to hold open incisions during blunt dissection and raising of vessels. So here you have on the right-hand side, the formal name for this is a Whitney incision spreader. It's basically a spring-tensioned incision spreader. You make your incision, you put it inside, you let it go, it opens right up. The retractor on the other side, this is something you're going to put in there and you're going to open it up, it's going to lock into place. So the benefit of the locking one is once you get that thing open and locked, it's good to go. The disadvantage of the spring tension is if the tissue is pushing too hard, you're not going to get the opening that you want. Most funeral homes actually keep a Whitney incision spreader, the spring tension, rather than the other one. At least that's been my experience, and that might just be the places I've worked. Ligature is used to close incisions as well as the entry sites used for trocar. Ligature is available in various cords or twists. 3-cord means there's 3 thread fibers that make up the actual ligature. And they also come in 5 or 7, which is the number of cords that make up the ligature. So 3 is usually the finest and the thinnest. 7 is the thickest. A lot of people like to double up their ligature when they're suturing. And the problem with this is when you do that with very thick ligature, the 7-cord, you leave these open holes, right? Your ligature is meant to go through the hole, fill the hole, and then move on to the next thing. When you double it up and you push it through, you might notice that the hole is larger than the thread fills. And that can cause leakage. So where this doubling of thread came from is people buy 3-cord because they don't want to have to buy different sizes of ligature, and then they double it up to make 6, which is sufficient for long incision suturing, and it's very sturdy. Better practice would be to buy 3-cord and 7-cord and use them for the purposes intended. Suture ligature is available in nylon, cotton, and linen, waxed or unwaxed. I have a preference for waxed. I'll take waxed every day of the week. And just about every funeral home I've ever been in, they always have a thing of dental floss for very fine suturing. It's easily concealed with mortuary waxes or cosmetics. You could use a device called a threader or passer to pass ligature between a vessel. You see it right here. You could take that and just kind of push it underneath. Most professionals will just take it, pull off a length, cut it, and then use your aneurysm hook or needle to get it under. Everyone has different preferences on the type of sutures they use, waxed or unwaxed. There is no right or wrong answer. The general policy is if you anticipate leakage, you probably want to use a waxed suture because it is more resistant to absorbing and wicking liquids. If you're using an unwaxed suture, it will likely wick, especially if you're using something like cotton or linen. We're now going to look at injection instruments. First up are arterial tubes. The formal name for this instrument is an arterial tube. A lot of people refer to them as cannulas. These are not cannulas. In our parlance, we call them arterial tubes. That is the proper name for this instrument, period, end of story. Okay? So many people get this question wrong because their embalmer, their preceptor used the word cannula. They see arterial tube, they see cannula, they choose cannula. You got the question wrong. It's called an arterial tube, period. Full stop. And there are many different types of these, sizes, lengths, etc. Generally, where the tube goes defines how large and thick it is. So carotid tubes are tended to be very short in length, but very large in diameter. The hub of the arterial tube is the attachment end. So here is the hub, right here. Numerous hub styles are available. Everything you see on this screen looks like a threaded hub, so it screws into place. The options you have are slip hub, quick connect, lure lock, or threaded. So what you have here is a you have a slip hub attached to the end of this arterial tube. Now, what you've probably noticed is there's this cork washer right here, which means this is a threaded end, and you have screwed a slip hub onto it. This is also quite common. People buy screw hubs, and then they attach all the different attachments they want. Whatever attachment you see, that is the attachment this is. So this is not a screw hub, this is a slip hub. You take this, you push it into the hose, and that's all there is to it. Do not look for anything more. Keep it simple, okay? There are some arterial tubes that are manufactured as a one piece. So you would not have this cork here. You would simply have the slip hub attached, and that's all there is to it. Which is why when referencing these, being shown a picture, you always go by the attachment you see. Never what might be underneath it, only what you see. A hairpin arterial tube is designed with a long shaft that places the attachment well below the incision space. So I did not realize there was something called a hairpin arterial tube. I don't think that was ever covered in the 5th edition textbook or earlier, but there is a formal name for these very long tubes that you can place into the body in, say, a deep recess, and then the attachment comes out. What this does essentially is it keeps your hose clean so that is not entering the incision site and becoming contaminated. Lure lock was developed exclusively for high-pressure injection. It attaches similar to attaching a hypodermic needle to a syringe. I understand that there are different ways of attaching hypos. Some of them are push-on slip hubs. Lure lock, you can see This is very smooth. This is very shiny. And this bottom that looks like a circle, this actually looks something like this. It's more of a rectangle with an oval edge. And you put it in, you screw it down, just like you would a screw attachment type. But because it's so much thicker, you don't have to worry about it pushing through the very fine threads and the arterial tube popping off. So lure lock really is about high pressure injection. I kind of prefer a lure lock myself because once this thing's attached, no ifs, ands, or buts, it's going to stay attached. Last chapter we talked about stopcocks. Best practice is making sure that these things do not leak everywhere when your machine is off. So what you see here is a stopcock. The stopcock is this unit right here. This is the stopcock. They have different types of attachments. So on this side, you have a lure lock attachment. You can see that there. This side is a slip. This I also think is what would be defined as a slip hub. And the way the lever is positioned, right now fluid will flow straight through it. If you were to turn this so it is now facing this way, then it would stop the liquid. This is essentially a valve and nothing more than that. You would attach this to your arterial tube, which you would then attach to your hose, and this just allows you to start and stop fluid as necessary. So when you leave your machine on, you close your stopcock, you do something, you open it back up. This is also extremely useful if you want to simulate pulsation. If your machine does not have a pulsation feature, you can just sit there and turn the valve on and off, on and off, on and off. Y-tubes were developed for autopsy embalming. You can embalm multiple limbs at the same exact time. So for instance, you could attach two hoses to the Y over here, and you would be able to do both arms or both legs at the same exact time. You also have something called a double Y tube. Again, you'd hook your hose up to the machine. Hoses then would lead to your arms. These would lead to your legs, and you can do 4 things at once. This is about efficiency injecting. You can also purchase these ready to go out the gate. And here's an example of what this would look like fully furnished. You have your Y tube right here. It's then screwed into 2 stopcocks. So if you're having an issue with one leg and this top one was good to go, you could actually kill the stopcock, which would then direct the fluid strictly to this one, where you could continue injecting that leg without having to take the arterial tube out or do something to stop the fluid. When you use Y tubes, that's usually a pretty good thing to keep in mind. What happens if one thing finishes embalming for whatever reasons? Turn the valve. Now everything flows into the second one. You can just focus on that. Hypovalve trocars are designed for hypodermic injection only. These are not intended to aspirate fluid. The valve is a thumb control, and there are different versions of these hypovalve trocars that are out there. Some are little metal blocks, some have these Delrin handles like you see here. And what you would have is you would have a hypovalve trocar tip on this end. When you push the lever down, that's when fluid goes through. And on this end, you can see it has a metal quick release. You would attach that end to the hose to your embalming machine. And this would allow you to use material in the embalming machine to do hypodermic injection of valves, deep tissues of the buttocks in an autopsy case, stuff like that. Drain tubes are drainage devices. They're inserted into a vein towards the heart. They keep the vein expanded. It can be closed to build circulatory pressure. And there are also stirring rods, which you can activate to kind of break down any large clots in an attempt to keep things flowing out. So here we have an iliac drain tube. It's a soft rubber or a rigid rubber that's very flexible. You can push it in there. This end goes into this end. Come on. This end is what would go into your vein, and then you would open this all the way, and fluid would come out the nozzle. If you want to close it, you push the valve shut, and this allows for the building of pressure in the line, which can increase diffusion and distribution, and we will talk at length about that in future chapters. Here is the most common type of drain tube. We'll have a body. We'll have the area that goes into the vein, and here is where the drainage would be. And as you can see, with the plunger completely depressed, you have a tip that goes into the artery, and you can see that there's a little hole right here. So once you insert this, what you're going to do is you're going to pull the plunger all the way back, and this is going to allow fluid to come in from the front as well as the side. Typically, these will be clamped in place. They may also be ligated. Fluid will come in and then come out the drain there. Axillary drain tubes are slightly curved and smaller in diameter. Axillary drain tubes are ideal for small femorals and iliac veins in infants. Hosing attaches to the slip hub, as you see on all of these. These are all versions of drain tubes. All these slip hubs is where you put the hose. You can see this one has a more pronounced hook on the end of it to grab and break things. These have 3 drain holes. Usually these are on both sides, opposite each other. Fun fact that with the tip completely depressed, there is still the possibility of material coming into this, just not the big clots, because what's going to happen is you're going to clamp this, somewhere back here. Liquid is going to come to where you've clamped and tied off, and it's going to force itself into the holes. Now, the diameter of the shaft inside is slightly smaller in many cases than the actual diameter of the drain tube itself. So if I have a drain tube this big, the tip certainly will fill this entire hole at its apex when it's completely inserted, but inside I may have a 3/4, something like that. So I have all this empty space around the shaft of the plunger where fluid can come in. So if you want to close this completely to build up pressure, you pull this up about halfway, which takes the tip from right here and places the tip right there, which absolutely blocks all the fluid coming out no matter what. There are also some units that you see where the space is much closer to the diameter of the outside wall of the drain tube. So if it's completely pushed forward, it is absolutely closed. Nothing's coming in there. Always inspect your instrument to see what it is you're getting into, especially if you're working in an unfamiliar environment, so you know whether or not you need to pull this thing back 1/4 or whatever. Drain tubes are advised for infectious embalming when containing drainage is necessary. It's also very necessary if doing Jewish embalming, where you have to collect the blood, as that needs to go with the body to place a final disposition. Now, angular spring forceps are the alternative to drain tubes. Forceps allow clotted material to be grasped and pulled from a vein. So we saw with the drain tube that we have the tube itself, and then we have the tip right there. Sometimes this tip has a little bit of a hook. All you can do is basically spin this and hope you break something up. Otherwise, this tube is going to get blocked, and that's all there is to it. Spring forceps allow you to really open a vein as wide as the spring forceps can stay open, and then when you close it, it will absolutely grab whatever is in there and then pull it out towards you. So there are some very strong schools of thought as to what people like to use. Me personally, I use angular spring forceps 100% of the time, unless there is a reason for me to be using a drain tube, like having to collect the drainage coming out of the body. I greatly prefer spring forceps, but they are an added exposure. They add exposure to the practitioner. No one can deny that. I just prefer them. That's my style. The last thing we have here is a grooved director. This is used to expand the vein and guide a drain tube or drainage device into place. The grooved director can also be used to guide an arterial tube into a sclerosed artery. Really, the goal here is this just makes it a little bit easier to put things into the vascular system. In some cases, you can actually use this as a drainage device, especially in small children, infants, smaller arteries. You put it in there, and this groove will allow you to get drainage out of the body. Deep breath, almost done. Moving on to aspirating instruments. So we did arterial injection, blunt dissection, and now we're going to go into cavity aspiration. We've mentioned this before. This is an autopsy aspirator. These are the 2 predominant types that are on the market today. The autopsy or post aspirator is designed with numerous openings, holes in the head of the instrument to prevent clogging. There are holes here on the side. There are holes at the very tip of this. These typically have slots all over the top, and on this side, the back of it, there is going to be, it'll look something like this. So here's the shaft, right? And then it'll have holes all around the perimeter, so that when this is lying in the open cavity, fluid is going into all these holes. On the other side, it'll look probably something like this. These come in a couple different varieties, but they all kind of look the same. So this is the back of this unit, and this is the top of this unit. This is back there. This is there on the front. The devices used to aspirate blood and arterial solutions have been collected in autopsied cavities. If you need to suck something out, this is basically what you use for it. Nasal aspirators are out there on the market. I am not a big fan of these. These clog so easy. If they get near any soft tissue, they basically stop working. The goal here is that you use this for very light aspiration work, surface aspiration, a little bit of fluid in the mouth. That's really all they're good for. If you put this in the nose, it's really intended to stay at the top of the throat, right here in the back of the mouth. You don't want this near the tongue or the side because it's going to just grab that soft tissue and stop. Trocars come in a variety of sizes. Trocar lengths and diameters are variable. Collapsible versions are also out there for traveling morticians. You can see here's a collapsible version right there. You can see that the trocar tip can be unscrewed from the handle. These are typically one piece. These smaller things here, these are cleaning devices. What you do is take the tip off and then you just ram the rod on through, kind of like a pipe cleaner. These are a new device. These are called Genesis injectors. These actually can't be used for aspiration. They can only be used for injection, whereas traditional trocars can be used for both aspiration and injection of chemicals. Now, trocar tips are replaceable, and you should swap these out because dull tips could lead to bad things. You have your preference whether you want these two-part types where you can just replace a tip or you replace the whole tip. Again, this just comes down to your own personal preference as a practitioner. I've used both of those types. I don't have a preference one over the other. They both do the same exact things. Generally speaking, infant trocars are shorter in length and smaller in diameter because you're dealing with smaller cases. They're also great for supplemental hypodermic injection in adult bodies. Me personally, I'm always going to go for a hypovalve trocar versus an infant trocar when hypoing flaps, but there are some people that prefer the other thing. Cavity fluid injectors, we just talked about the Genesis injector. These are the traditional cavity injection apparatus, and they work an awful lot on the same concept as the percolator. We're going to attach a hose to this end, attach that hose to a trocar, and that's what's going to go into the body. This then gets screwed on the top of a bottle, and what you see on both of these is this little air hole. So this is a straight pipe here, and it's very important that when you are working with your chemical companies, different chemical companies have different size bottles. And the size of the bottle matters when it comes to your cavity fluid injector. So make sure you have the one that fits your cavity bottle. If you put one that's too short into too long of a bottle, what you're going to find is that rod is going to fill and you're going to be leaking all sorts of fluid out of here until you finally get it going. So what ends up happening is you screw this thing in, air rushes in. Okay, air rushes into the unit when you flip it over, and this allows the fluid to flow out the front while air fills the body from the back down, right? So basically, you can think of these things as straws. And the goal here is to flip the bottle as quickly as possible so air wants to bubble through the straw. And when it does, it prevents fluid from coming in. Air is a liquid, okay? Air it works just like a liquid. Air and liquid cannot take up the same space, right? So if you have air in the tube, it's going to want to push out. It's going to want to rise, and when it does that, it forces fluid out of the way. Once the air starts, the fluid starts flowing out because that's the way fluid physics work. When it's done, you unscrew it, you clean it off, you go to bottle number 2. So a cavity fluid bottle, again, gets screwed directly into this unit. And then your hose attaches to the front. What you will typically do is keep your thumb over this, flip it upside down, raise it up, because the same principle as a percolator works here, that the higher it up, the more pressure will be created. Then you release your thumb, air immediately flows in, starts pushing fluid out of the way, and then continues to push fluid until the bottle is empty. When you looked at the Genesis injector, we'll go back a couple slides here real quick. You'll see that the Genesis injector, there's the cavity injector right there. That's the black lid. So really what you're getting is the handle and the shaft, and then you click a cavity injector into the Genesis handle. And that's how that apparatus works. Trocar buttons. You have a couple different ways to close up the holes that you make. You could choose to either do a suture, which we'll talk about the sutures that are appropriate for closing trocar holes. But most commonly, people use trocar buttons. It's a threaded nylon device, available in different sizes, different colors. You could also use these to close any other holes or punctures that may be out there. And people have different preferences for these. Some of these are threaded right from the tip down, so they grab better. Some of these have no thread at the bottom, so you have to push it in and then turn it until it catches. All this plays into which ones you purchase. Me personally, I do not like these that are flat on the tip. I want something with threading all the way to the tip, just for adequate closure. And the way you apply these is you apply them with a trocar button applicator. So you'll see at the top of these things, there's 2 holes. On this side, there's actually 2 rods right here. The holes are actually this open space between them. And you'll use the same applicator for either of those type of buttons. These come in these metal versions. They come in black plastic as well, like a lot of the other things that we've seen. Last up, we have feature setting devices. So we have eye caps. These are used to simulate, or actually not simulate eyes. These are used in place of, this is a closure device that is specific to be used on the eyes. So what you see is you have these sharp points right here, and these puncture holes here creating sharp surfaces, and that's going to grab the flesh on the inside of the eyelid and hold it shut. So if you're missing an eye, this is something that would go on top of a replacement, either a small wad of cotton or a armature intended to replicate the size of an eye. And these things come in all sorts of different shapes and sizes and colors. And all of these can be trimmed to need. It's really up to your business model if someone is going to purchase various sizes or only one size. Mouth or expression formers or plastic devices used to maintain closure and contour of the mouth. If you have a person that is missing teeth, it will be this is going to be used on top of some cotton or maybe just in front of the gums to kind of simulate proper line of closure. If you have natural teeth there, you may or may not need one of these. Some people use them on every case. Some people only use them if teeth are missing. That just comes down to personal preference. Your apprentices, your preceptors, they're going to be largely responsible for showing you, their preferred way of doing this. And as you meet other embalmers, you're going to meet new styles of doing things. So mouth formers may also be used over top teeth or dentures to enhance expression. Mouth formers are available in a variety of shapes and sizes, clear, opaque. So again, it just comes down to your preference. Needle injector is a manual device used to embed a barb attached to the end of a metal wire into the mandible or maxilla for closure of the jaw in a fixed position. Several styles of manual needle injector devices are available as well as an electric version. Those electric versions are extremely expensive. Needle injectors are great. Suturing is also an important technique that you learn on how to close mouths with suture. When I was teaching clinicals at my former employer, you would not use a needle injector. You had to get good at suturing in my lab because you're going to use a needle injector in every other case you're ever going to do. Me personally, I am not a big fan of needle injectors. The amount of time wasted in repositioning mouths, especially on the cases that I was working on, I would just rather go with the suture and be done with it. There are a variety of other positioning devices that are out there. What you see here are arm positioning devices. Most are constructed of metal, hard rubber, or plastic. There's tons of these on the market. Body rests and bridges. Here's an example of commonly available body rests and bridges. So you have your body bridges down here. You would place one of these at the base of the hip, one of these at the shoulders, and some people place one actually on the heel of the feet. This most commonly is also used on top. This item here, I've seen some people use this, where here's the shoulders. I've seen some people use this as a way to get your legs elevated for better distribution. I've had it flipped on the base, and they use the long end to really get the legs up or something like that. Again, there's just numerous positions you can place the body that are good for you while prepping. Head blocks, every body should have a head block under it when you bring it in. Make sure you take out the head blocks if it's a direct disposition so you don't end up inadvertently cremating these things. They do make styrofoam ones. You see a styrofoam head block right here for that purpose. As your book stated, when a body comes into the funeral home, they should be stored with the head elevated so that you don't have any dependent swelling in the soft tissues of the head or neck. Disposable styrofoam block is great for that. I've seen some funeral homes that actually take chemical bottles, tape them together, and then use them as a head block. So that way if someone forgets that you're out some empty bottles and not a head block. There are various ways that you can get those heads propped up. Finally, you have plastic garments. These are used to keep leakage controlled. There's a variety of these. Pants will cover the torso from the lower abdomen to the upper thigh. You have coveralls, which are the upper thigh to the armpit. So these descriptions are very important. Visualize where they're at and how they are used. Coveralls go higher on the body. Pants are basically shorts, okay? Stockings cover legs to feet. Sleeves cover the arms and wrists. Shirts are basically covering the arms to the lower torso, generally to the waist. You have capri pants, which basically cover everything from the waist to the feet. They're basically stockings attached to pants. And then unionals cover everything except the hands and the face. Now, there are multiple sizes of these. These have a finite life to them. If you store them too long, they get brittle. These tear very easily. There are tons of ways that if you are in a pinch that you can create things. You would be surprised how functional just a contractor grade garbage bag cutting the corners off and then using that in a pinch works almost superior to some of these plastic devices. At least I think they do. One thing to note is all of these devices, all of these have some level of cotton elastic where the holes are. All throughout here, you see that. They're on the edges. You're going to have cotton there. All of that is a leaking hazard. So when you put these on, you're going to be taping over them so that any fluid that does end up getting to that elastic does not wick and destroy your clothing and casket interior. Another reason why I think that just taking a contractor-grade garbage bag, cutting holes in the bottom, and then using them as a set of coveralls is superior because there is no elastic in there, which means that it's a lot easier to contain any liquid that may be pooling. Not advocating that everyone needs to go out and buy garbage bags as a matter of course. I'm saying that if you're between shipments or there is a shortage, that is one of the easiest ways that you can get something in there that is extremely effective by utilizing items that you can buy at everyday stores until your supplies come in. All right, folks, that finishes up this lecture. We will see you next time. Everyone take care. We'll see you next video.